Okay. Hello world. Ugh. This is day 182. Studying compilers every day until I land a compiler roll. I just woke up from a really fat nap, so, yeah, great. Last time we tried to fix the backend and we got completely stumped. This time I don't think much will change of that. We'll continue trying to figure out the backend and probably still get completely stumped. But yeah, it's gonna be a good time. Hopefully we get a little bit less stumped this time. Yeah, so git log. Or I guess, yeah, we have a lot of stuff that is not committed. And that's because I don't know what the hell I'm doing there. So, yeah, hopefully that's all resolved somewhat shortly. If we look at the log again, what we did at least do was, I guess, handling putter type sizes. So, which file does this live in? I think this is in data size. Yeah, so we handle the pointer type here now, which is wonderful. That is a positive change. Yeah, so now we still need to figure out a lot of this like tree gen stuff. So yeah, we are back in super hell. Yeah, where do we even begin with this? Oh man. Okay. Anyway. What we could do is we could restart all this. So we could actually get stash. Yeah, let's do that. So now we start from a clean slate, pretty much. So make build, and this should crash, I believe. Let's run build bin panic, test regression input. Let's give it putter. That's the test. So if we give it this, and then we do like, actually, what do we even do with this? What if we do O0? Yeah, so something still breaks. If we do this without O0, something still breaks. Regardless, we don't have any code. So, yeah, I guess we could start with non-O0. So let's start looking at this. Yeah, so a lot of evil comes from the way we represent pointers. So, yeah, so right now, all of our pointers, we're treating every pointer as just an allocate that we can go back to. So something is not right about that. Yeah, we're gonna need to figure that out. So, oh man, I guess we could like look through this slush as we go. We can figure that out. Okay, binary op. Is there an instance where we have a pointer in this? I don't think so. So I don't think we need to look at this for a second. Call, we probably don't. Maybe the return value actually, if it's a pointer. Yeah, so, I guess I shouldn't change anything. Yeah, that really shouldn't change anything. Yeah, right? Wait. Maybe I'm just going insane right now. Yeah, I did literally wake up like 5 minutes ago. So like this is a little bit sloppy. Allocate we definitely don't need to change. Load, I think we need to, I guess we should like figure out what we need to change. There's my alarm. I don't want to get copyright striked. Let's go Goover. Hopefully you're doing all right. Hopefully you're more awake than I am right now. So this load makes sense. Maybe we should look at our load node. Our load node. Okay, so it just takes a node for a pointer. That's fine. Okay. Is there a way I can turn off like auto translate in the chat? This is annoying me. Okay, well, I'll worry about that later. I'm assuming you're asking what time it is. It's like 9 o'clock at night. So I took a really late nap, and I'm sure I will not come to regret that choice at some point within the next 5 hours. Yeah, that will definitely not happen. Yeah. So hopefully I will be able to fall asleep later. Okay, well, so this is fine. We get the size. I guess this is all fine. This is fine, I think. Yeah, I don't think any of this really breaks particularly. Yeah, I mean, I think this is probably fine, surprisingly. I think this should all be fine for the most part. What's good, Nerd? It's good to see you. Yeah, I don't know where things are going wrong here. I don't think parallel copy is breaking either. Oh man, there's just so much going wrong. Okay, let's think about this a little bit. So we're trying to figure out something in load. Alright, so let's go to line 180. Fixing what? I'm fixing the backend right now because something broke with pointers. I guess resolve stack var is probably a big thing, right? Yeah. Oh man. I guess regardless it's gonna be an alloc of some sort. It's just like where it lives is gonna be really annoying to figure out. Yeah. Okay, let's rename this to resolve putter. And then we also need to rename it in there real quick. Okay. So let's actually go to the definition there. Yeah, so we automatically treat it as a stack variable. So the problem is we don't find it in the stack variables. I guess that should be the test. I guess, huh? So we can do this, and then if stack variables contains name, then we can do all of this slop. Otherwise, what happens if we just like, what do we even do with this? This is actually not much different from what we were trying to do before, right? So what happens if we just paste this here for now? Just for fun, let's we'll just make RSP. What if we just do that? Okay, that's pretty funny. What's good, Israel? The context for the stream is I woke up 10 minutes ago from a 9 o'clock at night nap. You might be sitting here thinking that's really dumb of you, and you're completely correct. You should not take a nap that late at night, ever. Unless you truly do not care for your future self and just hate yourself and want yourself to die. I don't know. Regardless, try not to sleep that late. That doesn't sound very healthy. Yeah. I'm not gonna beat the dead horse here. Okay, what do we want to print out? LR ISL. Okay, so now if we look at this, I believe yeah, so like there's a couple of just like straight up RSPs here. But there are some things that are still broken. So like this return, which was something that we were running into last time, but I think most of this was pretty sane. Like these were fine, or these, we like figured out a way to address that. But I think most of the issue just came from the way we handled returns. Yeah, we'll figure that out in a second. I gotta use the bathroom real quick, because average waking up experience. So I will be right back. Yeah, don't burn down the house while I'm away. Okay, I'm back. Oh man. Y'all know the feeling when like life is just moving in slow motion and like, or not even like slow motion. I guess like, or like hyper speed, but like you feel like you're going in slow motion in the world. That's kind of how things are feeling for me right now. It is looking rough. Okay, let's lock back in for a second. Yep. Hello, dude, Brazil again. Welcome back. Okay, let's make this, instead of RSP, let's make this let's give it like, I don't know, EBP, just something completely random. So it'll be easier to figure out what is happening. Or I guess where it lives specifically. So we want EBP. Okay, so we're using this on DREF specifically. Is there a reason behind the purple hair or just for the hell of it? The original reason for it is a bit of a long story, but yeah, it's a bit of a long story, but for the most part, it's just for the hell of it. I think it looks nice. I think it's a nice like little branding thing. Just today, I was like getting into an Uber and it was really windy and I couldn't hear the driver, so like I called him and he was trying to talk to me and I couldn't hear what he was saying, so I was like, just look for the guy with purple hair, and it worked, to be fair. So it does have some benefits in that regard. So like, I don't know, I think like perceptually it's kind of useful to have, but like, yeah, it's a nice color, thank you. Yeah, I want to try some other colors. If anyone has any ideas of like what I could try, I think I would very much appreciate it. I could be convinced on blue, I could be convinced on red. I'm probably vetoing green. But I'm open to like pretty much any suggestion beyond like those 3 caveats. Hot pink, that could be fun. I'm definitely doing some sort of like salmon pink at some point for like a Yuji cosplay. That might be fun. Okay, so in this case, or guess, so this case up here is stack variable. This case is just a raw pointer. So if this is a pointer, we should just like, how do we do this? Do we want to do like resolve leaf or something? How do we even, what even are we doing with this? Yeah, I guess we could probably just yank this. I'll just paste that in here. What's your bedtime? Oh man. Like 6 a.m. maybe? I don't know. we don't talk about it. We don't talk about that. Okay. So we get the register. So this should be, we should call this like base. So we could yank this, I think. Like that. And then return. Let's yank all of this real quick. Okay, so we want base. That's the null pointer, and this should be 0 as well. There we go. So that should fix or at least like some of these instances. I think everything else is specifically generated by the return. So we're gonna need to figure that out in a second. So let's rebuild it. This is kind of the point we were at last time, where we kind of like reasoned through this much, but we couldn't really figure out where to go from here. Yeah, so like this is like kind of what we did. So this was fine. We had a problem with this, specifically with returning the pointer. Or I guess maybe we're losing the deref operator somewhere. That might be where it's going wrong. But like these look correct, for instance. Yeah, so like this looks correct. And then this looks correct. I think that's more than good for now. Yeah. I don't have a proper schedule too. Yeah, I mean, I don't think that's really great, to be honest. I want to like fix my sleep schedule at some point, but like there's just so much friction to that. Like, practically speaking, like a lot of my friends are like online at degenerate hours as well. So like, there is just like a social cost, I think, personally. And I also think like our culture has kind of glorified this whole like no sleep sort of thing. And that's probably not healthy. Yeah, I don't know. There's a lot of thoughts that would go into this, I believe. Okay, let's figure out this return thing. I think this is the only instance where something like goes terribly wrong. Right? What is even generating this? Like, there is a chance that this is just like undefined behavior anyway, and like we shouldn't care that much about it, but I still want it to like kind of function sanely. So let's look at putter. Yeah, I mean, okay, so so I guess these cases are like the two cases where there is like undefined-ish behavior. So like, yeah, I guess maybe. I would like to replace this though with like whatever that is. Let's try to generate a different test as well. What happens if we do like int star foo, and then we just return foo here? So let's do shoop. Okay, so like this is fine, right? So why is the other thing completely borked? Oh man. I guess it's like undefined anyway, so like we shouldn't care. Right? Is it undefined? I should probably check that it's undefined before actually saying that it's undefined, huh? Is returning a stack address undefined? Okay, yeah, so it is UB. Yeah, okay, well that's fine, I guess. It seems like our stuff works properly. Like we could be lazy and like call it a day here. Like I want to see if we can do better though. Well, so why is it getting like nuked at least? That's not what makes sense to me. Let's just comment everything else out. So let's take that. Okay. So the problem that we're running into here, again, this is like UB, but I want it to be like kind of correct-ish, or like programmer intent-ish, correct, sort of. Hopefully that kind of makes sense. Yeah, so like, what we should be returning here is, we should be moving RSP to EAX. Where does this reg1 come from? Right. Let's do it like this, and then let's do this, and we emit MIR. So now we can look at these side by side. So we have an alloc. Obviously that disappears. Okay. So I guess we need to figure out how to return addresses. Oh man. I guess it does make a mess when it's not just like a simple value. Although it should just be, oh. Okay, all good. Anyways. Okay, let's look at how we generate return. I think that is where the confusion is. So So this is just the store. So these two lines correspond with the ret putter one. So reg1 does contain the pointer. So it makes sense why this is happening. Or like in the MIR code, it makes sense why this is happening. So that is like, so we're moving something into EAX, right? So destination is EAX. So presumably this is what we're looking for. Yeah. So we need to figure out this resolve operand shenanigans. Yeah. So I think we just need to add something to resolve operand and we should be good to go then, right? In theory. So resolve pointer, resolve operand. How the hell do we check if this is a pointer? I guess we check the type. And then... Yeah, this is really complex. Not complex, I guess annoying. I guess we should check if it's an allocate. And yeah, if it's an allocate, then we should convert the stack variable. So let's do auto allocate equals, let's dynamic cast it, instruction allocate. So if it's an allocate, then we want to return stack variables. What is this mapping? What the fuck are we doing with this? Oh, I see. Okay. Yeah, this makes sense. We just need to make the address out of this. So we want... Oh man. Okay. Let's do... base. Okay, so what we want to do is we want to yoink this sort of addressing pretty much. It's just instead of making it with this like address node thing, we want to just straight up make an address object. So let's just throw this in here for a second. So this is fine. This should be RSP. Let's get rid of that. So we want stack address. Let's call it that. So OM, we want to get address. So the base is RSP. So this is null putter. And then we need the two immediates. So scale, I think, or we could just make, do we have like a 0 that exists somewhere? No? Okay. Oh wait, we can just do that, yeah. I guess that's fair. And then let's take that. Okay, that does not paste properly. Here we want the displacement is something. We'll figure that out in a second. I guess it's whatever the offset is. So we want to figure out offset. So offset. So that equals stack variables at allocate, I believe. Or what type does this take? It's a string. Not that then. How do we get the name again? Okay, let's do that. Let's get the name. So we can do that. So in here we want offset, like that. There we go. That actually came out kind of clean. So we have stack address. So then we can just return, or we can just return this even. Like that. There we go. Okay. I think this is the correct logic. Let's just rebuild this. Yeah, let's look at that. Yeah, there we go. Okay. That's a big sigh of relief. So let's go back to test, regression, input, putter. Let's uncomment everything. Let's get rid of both of those. And then let's do that. And then let's look at this again. Okay. So DREF is fine. That looks normal. This looks pretty normal to me. Or I guess we shouldn't make an address out of it, huh? Maybe we should do an LEA? Yeah, actually, I think that's what we're missing. We need to do an LEA. We need to use an LEA for its actual intended purpose of creating an address instead of, or for its intended purpose of computing an address instead of just using it to save operations, which is really funny. Yeah, so we don't want to load from RSP here. We want RSP specifically. So we want that. That's what we want, but this is what we're generating right now. Yeah, that's what we want to do. Why is there percent before the registers? I believe this is like specifically, I don't know like how it looks in other assembly languages, but at least that's how it looks in specifically like AT&T x86-64. I'm not sure how Intel does it actually. Let's check. Because I know Godbolt, this stuff defaults to Intel, right? Yeah, okay, so Intel doesn't have it, but if you look at the AT&T syntax, it has prepended percents, because we all hate AT&T syntax. So then the question is, why are you using AT&T syntax? And it's because it's what GNU's assembler supports, so, or GNU's assembler defaults to AT&T, so I'm just using AT&T and calling it a day. Yeah, in hindsight, it might have been a little bit troll to use AT&T, but you know, some mistakes you only make once, except you don't actually only make them once, and you make them again anyway. Okay, what the hell do we want to do here? Where am I? So we want to make an assembly node, I believe. Which is very cursed. Oh man. Okay, so let's do this. Or actually, we need to like make a temporary, huh? Oh, that's really annoying. How does your compiler work? I have a front end, a middle end, and a back end, I guess. I know that doesn't say a lot, but like, we're just outputting like ELF x86-64, and we're just gonna feed it to like an assembler and linker because I don't want to write that. Yeah. How do I want to handle this? This seems very annoying. Yeah, this is miserable. Where do we call resolve operand? Call. Oh, we do actually use it in a lot of places, huh? Huh, okay, well, great. Yeah, so we need to generate an LEA somewhere here. I don't remember if we... Yeah, I don't remember how we do the merging. If we merge these like assembly blocks. I guess we're already using an assembly block, so like it doesn't matter because it's already generated. What's good, y'all? Good to see you all. Yeah, okay. Let's make a... Okay. Let's make another assembly node. So let's stick that there. And then we want to like yank instructions as well. So let's put this there. And then we need to make an LEA somehow, which is not fun. I actually don't remember how I encoded this. Does it take an address or does it take the parts? So this lives in here, I think. Oh, it just takes an address. That's really nice. Are you going for an object-oriented thing? Not yet. I'm just trying to support pointers right now. So let me pull up the GitHub for reference. Because it has like the subset of C that I support right now, and it's quite limited. So what we're adding right now is just like basic pointer types, and then the address operator and the deref operator. So yeah. Eventually we'll throw structs in, but at this rate I think this is gonna take a while until we get to that point. So we will worry about that once we get there. Okay, let's make this. So this takes... Oh man. This should be size quad word, I think, because we're doing an actual address for the first time. Let's make this address instead. Yeah, let's do that. Structs are just a bunch of data clumped together. Yeah, they shouldn't be that hard to implement. I imagine it's mostly just like front-end stuff. The big problem is the way I handled types right now. So I have an int type, and then I have a pointer type that I guess wraps another type. So, yeah, the problem is we can't really support like arbitrary names. And that approach also will just like make a mess for like deep copying. So I'm gonna need to resolve that in some way in the future. I have ideas for it, but it's just like a little bit annoying. So, yeah. Do you work on this every day? Do you get time to work on this? I do this almost every day, or at least I try to do it as every day as I can. There are some exceptions here and there for like life, or like if something in some other part of my life is just like completely exploding and I need to like resolve that. But for the most part, if on an average day, I will be working on this. It's less like a question of whether I have time or not. It's more that I just like actively carve out time for it because, well, this stuff is fun and I find it a way to help me relax as well. So, yeah, that's kind of my take at least. We need to make a temporary. Oh man, that's so annoying. Let's go Savage. Yeah, do we have a way to make a temporary variable here? I feel like we should, but we don't. Well, that's not ideal. What do we put in this address specifically? We have a name of a thing. I guess we could put it into that, huh? Okay, let's just make a dest as well, I think. So let's make a register. This should just be like name plus temp, I guess. We'll just do this for a second. This needs to be big R. No? Am I stupid? Hello? Wait. Am I botting out? Where does this live? Operand? And size, that's what I'm missing. Data size. Let's do size. Let's set that to lir data size quad word. Let's do that. Let's make this size. Address, let's do dist like that. Yeah, okay. So this is like the source, this is the destination. So here we just we compute the address and we put it in dest, and then we should do all of this and we return dist, I believe is how we're handling this. Which NeoVim plugin gives you the function info? I think it's one of the it's something in my LSP pile. I don't know if it's just like the base LSP config stuff. I'm fairly sure it's that though. Yeah, I think it should just be like the basic like NeoVim LSP stuff. I'm just using like the default key mappings, which is I guess why I haven't added them here. Yeah. The default key mapping is big K, so like uppercase K specifically. Or that's just like hover, I guess. That's the mapping for hover. Okay. So let's rebuild this, and then let's run it, and we'll see if it's all good. Hopefully it's all good. I don't want to do a lot. This was fine before. Oh my god, we forgot to... Wait, where'd it go? What the f... What? Oh my god, we forgot to add it. Okay, let's fix that real quick. So we want instructions. Let's push back. Let's do that. Whoops. Okay. Wait for paint to dry. Do that. There we go. Perfect. So this all looks correct now. Yeah, this is all fine. Something else we could do is just like, if the offset is 0, we just give it... like, if offset is 0, we just give it RSP and call it a day. Yeah, let's do it like that. So let's condense that, and then so offset, if that's, I guess if it's, we can just do not offset actually, I think. Here we can return, I guess we should make RSP regardless. Yeah, so we can just do that. And then this is all fine. Yeah, there's a lot of really cool LSP keybinds. Also, like for instance, grn lets you like rename a variable. So I had dest hovered, so I can rename it to like something, and it renames all instances of it with like LSP. So it's not like a literal find and replace. It matches specifically the variable. So grn. Yeah, those are the two LSP binds I use the most. I don't remember if GED is an LSP bind. It doesn't seem like it is though, so. Okay. So this is all fine. Here we do need to generate the LEA. And then return the temp. Yeah, find and replace is nice until like you find and replace things that don't match. Also, grn works between files as well. If you have like a header file, for instance. So if I rename like get immediate here, it also renames in here. Alright, let's rebuild it again. This should save a little bit of fluff. Okay, so we just return RSP here. Nice. Okay. Okay. So I think that's kind of everything, actually. Let's see. So what if we just go all the way now? Okay. Let's see. Let's give it -s. I mean, it looks mostly good. We're gonna need to do a little bit of cleanup, but. So what happens if we run it all the way again? Oh man. So let's do that. Let's give Clang this, and this will be easier to look through. Invalid operand. Where the hell? Can you run that generated assembly? We're getting very close. There's just like a couple of things that broke that we need to fix. But we're pretty much there, actually. Yeah, we just have like the incorrect size for some things, I believe. Yeah. I think this is fine. I think that should be fine. Oh, wait, duh. We need to account for more sizes again. So let's look at putter.s. It's line 5. What? Why am I... Oh, I see. Why am I using EDI again? man. I think it's because I'm like still hard coding a lot of sizes. Yeah, so we have like 9 things that are hard coded. So this should change. This is like nigh unreadable. Yeah, this is not fun. Let's actually just make an if else here. Instead of using this slop, because we're also going to need to figure out size as well. Yeah, so let's yank that. Oh, wait, we need... Okay, let's just double ternary operator this. What could go wrong? So we can do that. We can do something like that. If it's a stack arg, I think we can just... Man, I hate making these assumptions. Where's our get stack arg thing? Okay, there's so many moving parts we need to clean up here. I kind of want to just put this off till next time, to be honest. I think we've done a good job reasoning through this. And I kind of also want to enjoy my evening like a normal human being. Maybe take another nap past 8 p.m. and make another bad decision. What I would do for structs is just have a char star buffer. And if you mem copy an int at buffer 0, it'll get the first 4 bytes and put it inside the int. I see what you're saying, yeah. Yeah, padding is also a concern. Yeah, I don't think it would be that bad. It's just like the only big thing that isn't supported in my infrastructure right now is just like the type system. But I think part of this whole slush is like trying to work that out. So maybe that isn't as far off in the future. Yeah, we will see what happens. At some point, I do want to focus more on like middle end passes again, because that's all just like more interesting to me in terms of like optimization potential. But yeah, we'll see what happens at least. Okay, I think we are just gonna save this for next time. So let's get rid of that. Let's add everything. Fix tree gen with pointer types. Okay. So we're gonna push that. And I think we will just call it a day here though. Yeah, I'm just quite tired, and there's also like a little bit of other random stuff I need to do, so I will call today's stream here. Thank you all so much for showing up today. If you haven't already, make sure you like and sub to the channel. Yeah, that helps out substantially with the algorithm. And while you're down there, check out the description. My Discord is there. It's the best place to get pinged when I go live and stay up to date with I guess the rest of the community. Everyone is really chill. And there's some really funny discussions that happen. Aside from that, my LinkedIn and my GitHub are down there, and my GitHub sponsors is also there if you wish to support me financially. Yeah. Next time, we're gonna hopefully fix the rest of the backend and make all of the code generate, and it's gonna be a good time. Take care, y'all. Take it easy, and I will see you all tomorrow.